Okay, another important part of programming are if statements. And so these allow your code to do different things if different conditions are met. So you can use if-else statements to make decisions regarding what to do with certain types of data. So to give you some example of this, let's create a vector from 1 to 10. So we can call this myVec, and we're going to assign to it the values 1 through 10. See, so hopefully you're already getting used to vectors. Now, we can have it go through a list and call any value that's less than or equal to 5 small and all others large. So this is going to combine a loop with an if-else statement. So again, you can type this command in your upper left-hand portion of the RStudio workspace, and then hold down Control and hit Enter, and it'll run all this. But let's walk through what this means. So we need to step through every value of our vector and then decide if it's large or small. So to step through every value in our vector, we need a for loop. So we're saying for I in 1 to, now we could say we know our vector has 10 spaces, so we could do for I in 1 to 10. But then if our vector changes sizes, our code won't work. So this is where the length command comes in. So now we can say, okay, for I in the values 1 through the length of our vector, which is 10, so this will be 10, but now this code will work regardless of how long this vector is. Whereas if we put a 10 in here, it would only work as long as our vector has only 10 positions. So using the length command allows our command to work regardless of how long this is. So, but in our case, the length of myVec, the value here is 10. So I is going to step through 1 to 10. And then we're going to need to set up this if-else statement. So what we want to do is say, okay, so the first time through the loop, we're going to say, okay, is the first position in this vector large or small? So we're going to say if, and then in parentheses, if the first position, so remember, I is going to be 1 the first time through this loop. So if myVec I is less than or equal to 5, then you have what you want to do. If that's true, you put that in these curly brackets. Then we're going to print small to the screen. Otherwise, else, and then what to do, you say what to do if that's not true. In other curly brackets, we're going to print large. So what this is going to do is step through each position in our vector and tell us whether or not that value is small or large, right? So the first time through, I is going to be 1. So it will be in myVec 1. And so in this case, the value will be 1. It is going to be less than or equal to 5. So you should print small to your screen. So if you run this, you should get small 5 times and then large 5 times. Okay, so you'll get practice with these throughout the course. Like if you're still fuzzy about for loops and if-else statements, that's fine. We're gonna use them almost every day in this course, so you'll get very used to them. But we're gonna move on. So just some good programming practices. There's a few things to think about. First of all, you should use comments extensively, in your R code. So you can do this because R will ignore lines that start with a pound sign. So you can use that to make notes about what's happening. And so your code should have enough comments that someone could read them and understand what your code is doing without any explanation from you. So your code should speak for itself and to you, right? This is the same thing as like keeping a good lab book and things like that. Is your code should have huge amounts of notes. Your notes won't affect how fast the program runs, but they will provide you information of what's going on. So for example, here I mentioned that I wrote an R package for relatedness, and this is some of the code for that. So here's this code. The package has many functions. So this is one of the functions, And so you can see I have a description about what this function does. And because each line starts with this pound sign, R is going to ignore it. But these are notes to myself and to anyone who wants to look at the code. Anyone could open this up and see what's going on, right? So I have kind of explaining what's happening at each step of the code along the way. And so again, you should use notes very copiously throughout your code so it's very clear what's happening. This is more of code. So just for each for loop and each if statement, I have just notes to myself. What are we looping through? What are we checking for this if statement? What calculations are being done? And things like that. Another good programming practice is to use tabs. So you should indent nested processes with a tab. So what I mean by this is anything wrapped in brackets should be indented with a tab at the next level. So this includes functions, for and while loops, and if-else statements. And what this will do is make it clear what is contained within each process and when each ends. So for example, everything indented in this code, everything indented to this level is within the same function, which I haven't shown here, just fit it on the screen. But you can see here's a for loop. So now everything within the curly brackets of this for loop is indented again. So this makes it clear that all of this is happening inside this for loop. And now I have an if statement. So now everything in here is happening inside this if statement. And then I have another for loop here. Oops. So everything inside this for loop is indented again, right? But so this makes it very easy to tell when each for loop or if statement starts and when it stops. You should also use horizontal space very copiously. So R ignores blank horizontal space. So you should use horizontal space to make code easy to read and to make it clear what commands are closely associated and which are not. So I like to use space between like explanations, but then I have the actual code right below that, but then I leave space before the explanation of what's happening next. So R ignores all of this horizontal space that's blank, but it really helps make the code easy to read if you leave spaces between different things that are happening. You should also use vertical space consciously. So R also ignores blank vertical space, but you should use this to make your code easy to read. So for example, you should use single spaces around qualifiers or modifiers. So around either your assignments and other things, but not after parentheses or brackets. So for example, your code should look like this. So here I have a space around the assignment character. I have a space after a comma. I have a spaces around this, and so on. So it should look like this, not this. So here, if we don't have any spaces around these assignments, it can actually get easy to get lost and kind of lose track of where different things are, whereas it's much easier to read if you have vertical space between these assignments. You should also put a space after but not before commas, right? So having a space here and here, this makes it easy to separate out what's what, right? Whereas here, if there's no space after the comma, it makes the code harder to read. Okay, so this might all sound picky, but clean and clear code is a beautiful thing, and it will make your programs more usable and reproducible for yourself and for others. And so it's good practice to have good programming practices. It's like keeping a good lab book. Okay, that is our intro to R. I know that was a lot. I think that's our longest number of videos that we'll have. We'll see. I don't promise that, but I think so. But hopefully that makes sense. Keep track of any questions that you have, and we'll deal with them during class time. All right, see you soon.